Okay, welcome to the 11 o'clock session. Alternatives to PFAS and firefighting foams. Okay, by this time, you probably know the announcement I'm going to make that some licensed site professionals have paid to obtain continuing education credits for the conference. If you have not checked in at the front desk, you're not going to get those credits. You have to do that first thing in the morning, check in before lunch, check in after lunch, check in at the end of the day. So you LSPs out there that want credit, make sure you follow those rules. You've been told this over and over again. Hopefully it has sunk in. No partial credits are available for early or late. Okay, we're going to start in. Our first speaker will be Shannon Thomas, of Global Emerging Contaminants Program Manager at Wood. Shannon is a Vice President and Global Emerging Contaminant Program Manager for Wood. She has more than 20 years of experience in environmental consulting, including 14 years supporting per and polyfluoroalkyl substances. You know what those are. She has extensive program and project management, human health risk assessment, data management, GIS, 3D visualization and animation experience, and has supported state, federal, and industrial clients with PFAS evaluations. She serves as Wood's PFAS work group lead and has supported PFAS projects in 32 different states, in 9 of the 10 EPA regions, as well as Europe, Australia, and Canada. I'm so envious. She also currently serves as an AFFF leader for the ITRC PFAS team. Shalene?
All right. Good morning, everybody. Thanks for joining. My presentation seems to have a mind of its own and moving ahead for us to keep us on time. So I'm going to talk about the status of use and transition path forward to fluorine-free foams. I feel like the comedy warm-up act. Before Shannon and Molly, I've worked with both of them and really excited to see their presentations and grateful to be on the panel with them. So I'm going to give you an overview of status from my perspective on what's happening in the AFFF world, as well as the fluorine-free movement and transition. So show of hands, just before we get started, how many people in here are really environmental? I'm guessing this is most of the room. How many are firefighting foam, engineering? Hi, Steve. That's great, and what I anticipated. So the issue is really complex. I think the last 2 days were all about the human health and environmental component. We got this down. The challenge is that that problem is not just human health and environmental. It of course includes performance specification and standards. So that's looking at the engineering specifications of the foams themselves, as well as engineering and design requirements of those foams for application. And then operation and use. Let's not forget why we're here. This is the fire user community that's impacted the most in terms of how are they managing their day-to-day in terms of what foams they're using, why they're using, when they're using, and impacts to them in human health. So I prefer the message to be today for you to open your horizons past what we normally go down our environmental path and inform yourself with these other two, what I'm calling my fire triangle. So it's not heat, oxygen, and fuel source, it's human health, operation, use, and performance specification. The key items we want to consider when we're looking at those other two facets is it's not human health and environment. We know fate and transport, we know remediation, we know investigation. It really depends for operation and use and performance specifications, who are the users? So when you're looking at DOD and airports, they're of course driven by Mil-Spec 24385, driven by mandates through the National Defense Authorization Act, and driven by DOD's take to transition to fluorine-free foam. When you look at industrial users, they don't have that mil specification requirement of a fluorinated foam. They have UL, Underwriter Laboratory, EN standards. They have several other NFPA standards that they have to follow. None of them require fluorinated substances for fuel fighting or for firefighting foam. When you look at the municipal users, again, there's no driver for them to transition other than state regulatory requirements. Their foam specifications are across the board. Their operation and use could range from one end of the spectrum to the other. So you have to consider these elements when you're looking at AFFF and firefighting foam, not just that environmental perspective. So I challenge you to do that when you're going along in your work. And I'm assuming you're in here because you're interested in AFFF and have some reason to learn more about it. So just taking a step back on the ITRC team, chapter 3, myself and sub-team lead colleague Richard Speece from Vermont DEC. The chapter starts with all class B foams, and we all know they're not all created equally, right? We have fluorinated foams, not fluorinated foams, but they're all intended for the same purpose. So for fighting flammable and combustible liquids, oils, gases, solvents, alcohols, and the like. The key focus of our ITRC document is that top left box, the aqueous film forming foam, and either the legacy C8 foams that are through electrochemical fluorination, or the fluorotellerization process, or the modern fluorotelmer foams. So that's some of the things we're going to be focusing on today. Just one other baseline thing, the typical composition of AFFF, and I thank Steve for this. This is in one of the chapters that he wrote for the book referenced here, and I adopted it for the ITRC document. But AFFF products are not a bucket of PFAS. They are, in fact, like this is an example of a 3% solution. They are, in fact, a multitude of a mixture of things, anywhere from 20% or less of solvents. You have 60% or less of water and diluent. 15 to 18% is surfactants, but only 2% of that is actually PFAS. So now that we have a background, we know our fire triangle, which is not the fire triangle you all know, but human health, performance specifications, and operation and use. Let's compartmentalize those out and just talk a little bit. My intent here is just to give you things to follow up on, information sources and things that I'm seeing across these 3 different facets. So on the human health and environmental side, ITRC is still going, much to my chagrin. But we are working, we did just complete a update in December of 2021. Some really great content in there that was added around foam inventory and characteristics. Our intent there is, I always get asked, well, I have this historical site. Have you ever heard of this foam? What do you know about this foam? So our objective there is to gather as much information as we can of those historical foams and put it in a table so that users can identify, go back to that as a source. For case studies in the US here, not a substantial amount of case study information. We tried to gather anonymous case studies from different sectors so you could see what others were doing. It's not an edict, it's not a best management practice, it's just information. So my call out to all of you for 2022, our plan is to update both of these things. If you have case studies, know of people that have case studies, we don't care if they're in the US or otherwise, we want them. Similarly with foam, if you have them, we'd love to have that as well. We will also be adding a new regulatory tracking table that's going to be including all of the foam regulations that are happening, as well as products and other items that are happening regulatory wise related to PFAS. So hopefully we can all stay on top of it better. So another thing happening again on the human health and environmental side, I'm on the advisory board for this firefighter cancer cohort study. I bring this up, there's a lot of great, obviously, research going on, but this one I love, again, because it brings the 3 parts of the triangle together. So it's looking at PFAS exposures in the fire service, and it's trying to look at different types of exposure, different types of fire service membership, and they did just have their first publication here in October. Moving on to operation and use. Again, Another one that's a great collaboration, 3 parts of the triangle here that I'm involved in is the NFPA Research Foundation. So this is a firefighting foam roadmap. What they're ultimately trying to do is they have airport DOD representation, they have municipal fire representation, they have industrial oil and gas fire representation. They're trying to pull together all 3 parts and come up with common best management practices, data and knowledge gaps, and summarize trends in what's used in foam applications, what challenges they have, what's influencing performance. And right now we have a substantial draft that's in draft right now in comments. So we're hoping to get that published really soon. But the intent of this now is to develop a team that ultimately moves forward past this project as a way of collaborating to come up with best management solutions across the spectrum from environmental to performance to operation and use. So this next one on operation and use, some of the things that DOD is doing, they've now racked and stacked their inventory of fixed and mobile systems. So that's a good news. First thing of any problem, recognize you have the problem and then identify the magnitude of the problem. The unfortunate thing, they're looking at over 4,000 systems now across their fixed and mobile assets, which is 3 million gallons of firefighting foam. The other challenging part to hear about this is that estimates for the civilian airports, when you similarly look at that, it's anticipated to be 3 times larger than what you're seeing in the DOD. Estimates for municipal and industrial, I have question marks there. We've done some use study works for ECA and European Commission in Europe. Oil and gas was top of the list. Oh, fire. I didn't mean to do that.
For those online, we have a fire alarm, so we'll be leaving. We'll be back, hopefully.
We work together. Yeah. This is nothing.
Officially, we can't be here.
Okay, good. Thank you. Right. We needed air.
Yeah, I needed air. I don't know about anybody else. The funnier thing is that's the second time that's happened to me. I'm starting to think it's me. I don't know if there's anybody in the room that I'm that boring, you're gonna pull the fire alarm, but oh well.
Okay, I'm going to start your timer again.
All right, let's do it. As we were. All right, so now moving into the performance specification side of the triangle. Some key things that are moving forward in AFFF and considerations, of course, under the NDAA. So January of next year, DOD is on point to publish the mil spec for fluorine-free foam. That's not the end, that's just the beginning. So once they do that, they're identified maybe I think 4 to 6 different foams that they're looking at further that we anticipate will go through the certification performance specification process, become certified by fall of next year. By fall of next year, that's when DOD will identify that you cannot purchase foam greater than 1 part per billion PFAS. Following year, you cannot purchase PFAS AFFF at all. So they're anticipating by October the following year, magically, they'll be able to just move forward with fluorine-free foam. The Secretary of Defense does have the autonomy to grant 2 one-year extensions to 2026 on that. So we'll see where and how that goes. I fully anticipate that's exactly what's going to happen. This is super aggressive because it's not just about having the foam and changing it out, as we all know. So again, broken record for those of you that had to leave the room. Human health, performance specification, operation and use, 3 parts of the triangle. This is what's burned in your memory when you leave at the end of the day. Moving to the fluorine-free alternative aspect. So the DOD has spent a substantial amount of money looking at fluorine-free alternatives. So I think in the last 5 years, it's something like $28 million, and they've gone everywhere from the R&D spectrum, looking at toxicity, fate, and effects, all the way through looking at performance and alternatives on the ESTCP side. They are also not just looking at fluorine-free alternatives, but they are evaluating non-foam alternatives. So thinking beyond the box, outside the box, what else can we actually use? And evaluating the risks and costs of those various replacement strategies. They published a sundown policy rather recently. And in that sundown policy, some really alarming things. And so I have a risk management background. And so things like that, I just salivate about. What they did is they took 30 years of data across all of DOD, 15 years of, what do you want to call it? Incident data. Across the entire system, they did not have a fuel fire related incident that resulted in a death or in the loss of an airport or airplane, pardon me. In their mishaps, their 15-year mishap spill data, they had over 80 different spill mishaps, which averaged, incidental fire suppression system going off, accidental spill, 2 spills a month, resulted in over $24 million, 1 death, 21 injuries, and loss of property. I can't remember how many airplanes were actually damaged. What the point is here is that was all accidental release. Those costs were not associated with saving life and property, which is the whole intent of the foam to begin with. So I think the message here is if and where you can identify why, how, and when you actually need to use foam. What they ended up doing is putting their facilities into tier 1 and tier 2 facilities. Tier 1 facilities where it was mission critical, they absolutely needed it. If that asset was gone, they'd have problems. Tier 2 was, okay, it's not a mission critical facility. We're just using water. And so they've moved to water in all their tier 2 facilities. So it's just something to note for all of us that are just on this sometimes myopic path that we just need an alternative to replace fluorine-free foam. One quick thing happening on the global front, as we all know, because it's a global issue, oftentimes things in different parts of the world do impact and influence what we're doing here in the US. So this was a project that Wood did for the European Commission and European Chemical Agency. We do use studies for them to help inform their policy. We obviously don't make policy. This was published back in June of 2020, Why I'm talking about it now, because just February 23rd, they actually came out with their restriction proposal for AFFF. And they are evaluating, looking at sector-specific transition periods. So as I mentioned, you go back to the users, you're looking at municipal, you're looking at industrial, or you're looking at defense and airports. So they're rolling it out in a manner that seems a little bit more informed in my 3 parts of the triangle. Oh, did that move on me? Sorry about that. So take a look at that. They just had an information session yesterday. They're getting feedback from stakeholders. I think that happened last month, but it's an ongoing process and they're hoping to finally move that forward. The link to our report is there. That's also a good template to use if you have to do any type of use studies of your own to try and help inform your own policy. So hopefully I've given you a little bit of an indication of what's out there from the human health and environmental perspective resources that look more holistically and not myopically at one individual thing. Performance specification and things happening there. And then also on the operations and use side. So I've said again, I'm going to put this up there again. I'm sure some of you already scribbled it down, right? Consider this whenever you're involved in any circumstance, because this is the whole story. It's not the story that we all live every day. Go back to the basics and make informed risk management decisions. And I love this one. We're all thinking about, oh my God, we got to change to fluorine-free. Oh my God, how much is going to cost to decontaminate the system? And all of these things, how clean is clean? Who's going to validate that? Who's going to be the jurisdictional authority to manage how clean is clean? And I hear on the environmental people side, I've talked to someone in the state yesterday asking, we really want someone to develop this best management practice. And then I sit in with the fire user service side and they say, we really want someone to define how clean is clean. But really, most states don't have jurisdictional authority to say this is how clean is clean. It's up to what waste stream that you're discharging and what the merits and criteria are for that waste stream, like any environmental agency would do. And similarly on the best management practice side, us environmentalists are asking them to do this and they're still feeling like they need more information. So when I say go back to the basics and to that story of the sundown policy, think about the probability of occurrence. If you have to use foam, what's the probability of something actually is going to happen, that you're going to have to respond to an emergency? We now have done such a good job of managing and mitigating risk associated with training. We now have a better understanding on use. And if we have these incidental spills to, oh, it's not just soap, we actually do have to clean it up and respond right away. What is the risk associated with keeping a foam and managing and mitigating in an emergency circumstance and just refining your best management practices? If the probability of an emergency is that low and the consequence of occurring, you can manage and mitigate. So that's lower as well. You've met the intention at the end of the day. So I think that's it.
Thank you. Next up, we have Shannon. I'm going to mess up your last name. Poshu. Ah. She'll repeat it and correct me. And considering how many years I've known you, I just never say your last name. Shannon comes to us from the Connecticut Department of Energy and Environmental Protection, where she has been there for 22 years. She's the remediation division's lead on emerging contaminants, including PFAS and 1,4-dioxane, which doesn't get enough credit. It was appointed the agency's lead on PFAS in 2019. She was an active participant in the governor's interagency PFAS task force and a co-author of Connecticut's PFAS action plan. She has participated in the ITRC PFAS team, and in addition to her work with PFAS, Shannon has considerable experience managing the investigation and cleanup of state and federal Superfund sites. So welcome, Shannon. Let's should have done this. Okay, is that one yours? Uh-oh, we don't know the name of it.
Oh, it's nice. Have my flash drive. You scroll up to the top, maybe. I'm not seeing it.
Well, why don't you get your flash drive and we'll. Be sure to upload that one to the. Right there. This one?
Yes.
And voila. There we go. Okay, Shannon.
Thank you all. Thank you, Shailene, for a great setup, really interesting. I don't know about all you, but between giving a presentation and the fire alarm, my nerves are shot. I have no idea what's gonna come out of my mouth. Will that Zoom toolbar stay right in the middle the whole time? I'm just,
Let's see if we can grab that. Where would you like it?
just out of the way is
How
fine.
about down there?
Yeah, that's
Let's click on more and then look right down. It says
not end.
hide the meeting.
Hide.
Yeah, right there. Up
Right,
there.
this
Yeah.
it.
Yep, you can hide it.
Okay,
And
yeah,
then to change it, it's in the lower left or right there. What was it?
okay, thank you very much. Okay, starting again. Thank you all for coming. Shannon Pochu, the CI is like a CH, but that's okay. Okay, so anyway, I'm here to talk to you a little bit about what the state of Connecticut has been doing about aqueous film forming foam over the past several years. You'll notice this lovely picture in the backdrop, pretty much covered by my title slide. But that's the Farmington River in Connecticut after an accidental release of, ended up being about 30,000 gallons of legacy AFFF that discharged from a hangar at Bradley International Airport and went through the floor drain into the sanitary sewer system and through the sewer system into the Windsor POTW and discharged to the Connecticut River the next day with all the travel time. The actual accident happened on June 8th. And that was Connecticut's foray into PFAS. You know, all the other states had drinking water well issues and this and that. No, that was kind of low key in Connecticut, but no, we had the major surface water release and that definitely got everybody's attention. Although at this time, we were already talking about what we wanted to do to phase out use of AFFF. Okay, so about our AFFF Takeback Program. Actually, let me back up for a minute. This is actually going to be two presentations in one because Jennifer Griffith asked me to talk about our fluorine-free foam evaluation. So that's the first half. Second half, I'm going to update you on where we are with our Takeback Program. So as I indicated, we had begun planning for our Takeback program. Oh geez, talking about it, I remember, I think it was sometime in 2017, I went to our state fire administrator at our Commission on Fire Protection, Prevention and Control, too many acronyms, and kind of dropped the bomb. Hey, you know, your AFFF, it's really not safe to use. There are these health problems with the chemicals in it. When you release it to the environment, it's a problem. We can end up with polluted wells. So it was very difficult initially trying to get this message across, and even to some of our own emergency responders within our agency, who many of which are first responders in their hometowns. As Shannon said, this was just soap. It's soapy water. What's the big deal? It's like, well, it's actually a little more than soapy water. So we began that conversation, and we ended up collaborating between DEEP and our Department of Emergency Services and Public Protection on an advisory bulletin that was transmitted to all fire services in the state, basically telling them, only use AFFF if you really have to, no more training with it. And it wasn't a requirement, it was a strong recommendation. And it was also a reminder to them that anytime they deployed AFFF, they should really be calling emergency dispatch at our agency to report the release. So around this time, we were also convening our state's interagency PFAS task force. And with the release that I just showed you to the Farmington River, that resulted in a fish consumption advisory, as in do not eat the fish at all, for a year on that river. It got a lot of press. The legislators were interested, governor's office knew about it, and we made sure we included it in our action plan, that one of the key things we wanted to do as a pollution prevention measure is see what we can do to limit future use of AFFF in these accidental releases. We got some bond funding, so we're like, yay, we can start a Takeback program. And but before we do all that, you know, again, Shannon's fire triangle, you know, use and performance. Fire services have a job to do. Their job is to protect human health and, you know, life and property. So you can't take this off the shelf without having a replacement for them to use. So I'll talk more about that on the next slide. And just to, you know, we did find an alternative for state use. And last year we had a state law go into effect, banning use of AFFF upon bill passage for any training. And it banned most other AFFF uses effective October 1st last year, with several exceptions. And I'm happy to share my slides. All these blue highlighted lines are links to the relevant documents and regulations if anybody needs additional information. Okay, so the State Fire Administrator back in 2019 convened a next generation foam committee, and it was comprised of himself and one of our emergency response coordinators who's since retired, Jeff Chandler, great guy for any in the service who know him. I kind of invited myself to the game because I was concerned about potential replacement chemicals that would be regrettable substitutions. And to the extent that we could find an environmentally friendlier alternative, that would definitely be preferable to another 20 years from now saying, oh, well, remember this compound that replaced PFAS and AFFF? Well, hey, guess what? That's bad too. So we've been there, done that. We don't want to do it again. We also had good representation from municipal fire department leaders, a representative from the petroleum industry, who was a retired fire chief who worked for one of the terminals in New Haven. And we also had colleagues at other states join us, Mass DEP, Rhode Island DEM, and Mass DEP, who were following along with our work. You know, this is an issue everybody was concerned about. We're like, yep, come on along. Let's learn about this together. So with this fluorine-free foam evaluation, the committee chairs invited different vendors to come and show their wares, if you will. And we learned that some of the firms that were, some of the vendors that said they had fluorine-free foam, well, guess what? As I dug into it, it's like, this particular foam meets the mil spec and therefore it has to contain PFAS. So no, that should not be a contender. So it was a question with some of the vendors not even knowing what they were selling, or they thought that, well, yeah, it's PFAS free. It doesn't have any PFOA or PFOS. Okay, that's 2 out of thousands. No, we're looking at PFAS, like no added PFAS. We took a look at what Green Screen had, which at that time, they had a few fluorine-free foams on the list. It's much longer now. And they also talked with the Last Fire representative. For those not in the know, Last is a large atmospheric storage tank. So I envision those huge oil above ground tanks that we have down in some of our harbor areas for petroleum. So these were the goals that the committee set out. They wanted the replacement foam to be effective on both polar and non-polar flammable liquids. They felt strongly that it should have NFPA and UL certification. We have regional foam trailers, which I'll tell you about in a minute. And we wanted to make sure that the new foam would be compatible with existing equipment. And we were also interested in a favorable laboratory report. So fluorine-free plus no regrettable substitutions, if we were able to discern that. Along the way, we had Nick Child, retired from Mass DEP, who was participating a lot with us. And we all had the same questions about, what's in this stuff? So at the time, Connecticut did not have funding for laboratory analysis, but Nick did. So he became our best friend. So we arranged to purchase off the shelf, like 5-gallon containers of different types of fluorine-free foam products and some wetting agents, and had them shipped to Mass DEP or to your consultant. I don't know exactly what happened, but anyway, the samples were analyzed at Alpha Analytical. They subcontracted some of the analysis to Harvard and Sterling. And we also, I want to give a shout out to Mark Smith from Mass DEP, who we had a lot of talks about, well, what should we be analyzing for? And then for sure in trying to digest the laboratory data. So we wanted to do total oxidizable precursor analysis. I was curious about semi-volatiles, although that didn't go very well. And then total fluorine and total chlorine, total bromine. This table I stole from Mass DEP's memo describing the analysis. So this is available publicly on Mass DEP's PFAS website. We looked at 6 different products: Universal Green, FOSCheck Fluorine-free, NovaCool, Knockdown, F500, and Firestopper. And basically the green was favorable, non-detect. Yellow, J flags, is it really there? We had some detections and method blanks. Red, we had confirmed detections of different PFAS species. Or in the case of the columns on the far right, total halogens. So, a word about this, our detection limits were really high. This is a hard matrix to work with. It's a surfactant, and the samples needed to be diluted 100 times or more. And whenever you do that, it raises your detection limits, which is a problem, was a problem for me to grasp, because our drinking water limits are in the low parts per trillion. And how do you reconcile that? And the bottom line is you can't. You got to make do with what you have. So yeah, I got a little ahead of myself, but the takeaways were, we determined through working with folks at the terminals that the F3 products we were evaluating were not going to be compatible with fire suppression systems, the fixed systems that have subsurface injection. I learned all kinds of things. So a lot of fire suppression systems will spray the foam from above onto the flammable liquid surface. In these large atmospheric storage tanks, many of them have subsurface injection, and I believe it's based on density differences. The AFFF would rise through the petroleum and form a coat on the top of the petroleum liquid surface, and in that way extinguish the fire. No oxygen, right? The old triangle. So it just, the F3 products, either their composition, density, it just wasn't going to work. They would become encapsulated by the petroleum. So, okay, so we have a limitation there. As I mentioned, the foam concentrate, really tough matrix to analyze. And our detection limits were pretty high in the parts per billion to parts per million kind of level. And it's, after thinking about that, it's like, you know what? I think green screen certified may be the best thing to do. The other thing is we can't be in the business of independently testing every single product out there. That wasn't a responsibility we wanted, and nor do we have funding to do that. So ultimately, based on product evaluation, there were tests. I actually got to go to one of the fire schools where they lit stuff on fire and they put it out with the new products. And so the first responders found a product they felt comfortable using. They felt it could replace the AFFF in the state's regional foam trailers. And they recommended, for now, National Foam Universal Green. So we'll move along to the next step. Okay, so that gets us to our Takeback program. Okay, we have a replacement, yay. And we have some money now, yay. We have $2 million bond money, some of which we can use for our Takeback program. Now that we talked about what would make sense for the Takeback. We knew, for example, for our foam trailers, we would need lead time to purchase the foam. And we also would need to potentially clean the existing fire apparatus. So with that in mind, we decided to divide the whole Takeback up into several phases. The first phase was just a container collection for stored AFFF from municipal and state fire facilities. It was launched last spring. Just wrapped up, I believe, oh boy, I gotta speed things up here. Okay. And so bottom line, we collected over 35,000 gallons of foam in containers from over 250 fire departments. It was a cost of about $800,000. I know everybody wants to know that. You're also going to want to know it was disposed of through solidification and landfilling because of the uncertainty surrounding incineration. The second phase was to look at decontamination of fire apparatus, and that's what I've spent a lot of time on recently. And the third phase will be to remove AFFF from fire apparatus and decontaminate, rinse to some extent, and that is pending funding. Okay, so our decon demonstration goals were, as Shailene, you did a great job. We're looking at risk reduction rather than complete elimination. There's no way that we could clean fire apparatus to such a level that we could drink from it. That's just not realistic. So looking at gross PFAS removal, how to do the cleaning and clean to what level, just like, we didn't know how low we could go. Can we minimize waste along the way, because PFAS disposal is very costly? And looking at cost benefit analysis. Are there some pieces of equipment that it makes more sense to replace rather than spend the time and energy of cleaning? And then what do we do with all this waste liquid that we generate? Can we treat it on site? Is it cheaper for offsite disposal? So these were the kinds of questions we had. And eventually, you know, we hope to refine our SOP for moving forward. We ended up putting out an RFP, soliciting for vendors. We ended up selecting AECOM, teaming with TRS and Hiller using perfluoride, and Arcadis using Fluorofighter. We have a total of 8 regional foam trailers. Figured we'd give them each half and go to it. I wanted to be able to compare what they were doing. Generally, we followed this sequence of draining the AFFF, doing a gross water rinse, and then each vendor was doing a cleaning solution and water rinse cycle repeated 3 times, sampling each step along the way. I requested that both consultants use the same laboratory, so there wouldn't be that sort of question. So we ended up at Eurofins Lancaster, PFAS, EPA people, modified 537 with isotope dilution, following the DoD QSM, and performed top assay on most samples. This is what the trailers look like. They're 500-gallon tanks with different proportioners and a transfer pumps assembly. Some action photos of the AECOM TRS setup. The silver tank here on the left, fluoride was mixed in that with the solution heated to around 100 degrees Fahrenheit, and filled the trailer with it. And then we drove the trailer around to try to get some contact time. Same thing with the fire trucks, circulate the perfluoride through there a couple of times. One of the key takeaways, all fire trucks are custom built. And the plumbing inside is like spaghetti. Okay, I'm gonna spend a minute on this, apparently 1 minute. Could I have 2? Okay, so again, you'll get these slides, you can look more closely. This shows the taller bars basically are PFAS total concentration starting points, around 15 million parts per trillion for the first trailer, and after 3 rinses with the cleaning solution, they got down to 8,000-ish parts per trillion. For the second trailer, I think we did an additional gross rinse because the AFFF was so thick and viscous, it didn't make sense to spend it on the cleaning solution. So we started with about 643,000 parts per trillion down to about 1,500 parts per trillion. With the fire trucks, similar results, ending up between a little under 1 part per billion up to 4 parts per billion. Again, this is not the top results, okay? The top assay results were generally 10 to 100 times greater for each analysis, to give you a sense of the precursors that are present in the AFFF. This is Arcadis's setup. They had a somewhat different circulation system set up to put their Fluorofighter throughout the equipment and circulate it for a number of hours, let it sit overnight. And due to some supply chain issues and delays, they only had time to do 1 trailer so far. Again, starting with the residual rinse, 7.6 million parts per trillion of PFAS, and after 3 treatments down to about 1.5 parts per billion PFAS. So, okay, lessons learned so far. I'll take a minute on this. There were a lot of delays. We had COVID impacts. We had supply chain issues. We had lab delays. We couldn't find truckers. It was like a perfect storm. So if any other states or entities are planning for this, it takes a lot of planning and logistics, and don't be surprised if there are delays. We had a hard time finding a location to do this cleaning. Some municipal fire departments that had great garage space didn't want to let us do it because they were afraid of future liability if something were to go amiss. A lot of coordination with fire departments. The vehicle draining and cleaning initially took a long time, being the first time you're going through. It's a pilot project. You know, what other things do we need to do to these foam trailers to make them serviceable after the fact? We want to hand them back to fire services, usable. Rinsate treatment versus offsite disposal. That is a big deal. We generated at each location 16 to 17 totes of wastewater, plus additional drums of carbon, flock, etc. It's expensive to get rid of. And our discharge limits, self-imposed, state of Connecticut, we could not discharge any PFAS to surface water or POTW. So the treatment goal was non-detect at the low part per trillion level. After attempting on-site treatment, we ended up having to ship the waste off-site anyway. All fire apparatus are custom. How many outlets do you have for the foam? One truck had 1, another had 6. 2 on each side. Disposal, enough said, it's a problem. What do you do with it? And I will note there would be an economy of scale. So once you get a cleaning location set up, it would be more efficient to do multiple vehicles. So I'm sorry, I went over a bit. Okay, and one takeaway. So this is definitely the right thing to do. You know, we want to get the gross AFFF with the higher concentrations of PFAS off the street. We have a lot of releases that continue to happen. And cleaning to some extent is definitely a good thing to do. After looking at the post-treatment results, we're still going to have parts per billion level PFAS in these fire apparatus, which will cross-contaminate our fluorine-free foam. This isn't going to be perfection, but it's going to be significant risk reduction. So we need to look at what deployment of fluorine-free foam means in the future as far as follow-up for potential environmental cleanup or evaluation of potentially public water supply wells, private wells nearby. Next steps, finish our SOP, do a cost-benefit analysis, figure out what we're doing and how much money we need, and then hope we get money. So, okay, thank you for your patience. I'm sorry I went over, but you're more than welcome to contact me.
No problem. Let's see. This one.
Should be just on the decks.
Okay.
I did see it in the file.
Good. Try to find it.
Sure.
Okay, one quick introduction. Molly Jacobs, Senior Research Associate at UMass Lowell. She's a Research Associate at UMass Lowell for sustainable production. Molly has over 20 years experience in public health research and practice. Since 2013, she has managed the Lowell Center's extensive alternatives assessment and informed substitution work, both of which identify and compare potential chemical and non-chemical alternatives that could replace chemicals of concern. This has included supporting governments in the US and internationally to institute programmatic and policy structures that advance informed substitution efforts. Molly's research at the Lowell Center has examined other environmental health issues, utilizing her deep expertise on the environmental and occupational causes of cancer and asthma. Molly Jacobs.
Awesome. Great. Well, I hope to make up a little bit of time. When you're playing the cleanup role in a panel, it's like, okay, how deep do I go? So I was asked by the organizers of the conference to focus on this work that we were doing under a project funded by DoD, but to focus more on the lessons learned rather than kind of the methodology and everything that we use. So I'm going to do that, and with that, hopefully make up some of our time. so that we have time for discussion and questions. So the work that I'm going to speak to today focuses on alternatives assessment. If you attended some of the sessions yesterday, they've been mentioned in reference to what's going on in California. Ray Eaton, who's here from the state of Washington, talked about some of the work that's being done on alternatives assessment in the state of Washington. But quick primer on what that is. Again, it's an approach and it's a tool used to support informed substitution, to get the information necessary to help inform a substitution decision. So it's a process for identifying, comparing, and selecting alternatives to chemicals of concern. And it evaluates multiple attributes that businesses, decision makers need to know in order to make the substitution possible. Hazard, also is essentially cost and performance. The field has grown over the last number of years to also incorporate other considerations, intrinsic exposure potential of the compounds or the technologies that we're going to, as well as broader life cycle considerations. There's a ton of work being done right now in Europe to move to safe and sustainable by design, right? So kind of broadening our thoughts, not just on safety, but also sustainability. And so the alternatives assessment kind of process is trying to do the same as well. And again, it just facilitates this comparison between options against those attributes in order to inform the best decision for that decision maker going forward. So I don't have to do a ton of background here, but Shannon did an amazing job setting up this panel. But all is to say, this is kind of setting up the work that we were doing on behalf of DoD. So as we hear, under the National Defense Authorization Act in 2020, required to phase it out, AFFF by 2024. The 2021 National Defense Authorization Act also helps with kind of providing these programs that Shailene mentioned to do a ton of research on the issue of alternatives that utilize green and sustainable chemicals that do not pose a threat to public health or environment. So kind of this is where our project came into fold. We were funded by the Department of Defense's Strategic Environmental Research and Defense Program. We did this work in collaboration with NOMOA, our gracious host for this meeting, as well as the Massachusetts Toxicities Reduction Institute. We had an esteemed group of committee members that helped support the project. Holly Davis in the back, who is a toxicologist at the state of Washington, was among our project support group. But what I want to talk to you today is kind of 2 of the 4 projects that we were involved in. And the first is kind of understanding the gaps in comprehensive alternatives assessments to date on AFFF. Again, our focus was on this question of alternatives assessments. How are we combining the information alternatives to inform decisions about what are safer and feasible substitutes to go forward with? I did have one other kind of objective that I wanted to put in here, and I think it builds on what our previous speakers have talked about. Another one of our projects was to understand lessons learned from adoption, from the implementation of alternatives. Alternatives assessment doesn't end with just knowledge of what are safer, feasible options, but going forward, doing the substitution, understanding what's working, what's not working, what's going to set us up best to have the best effective substitution programs going forward. And so we did an interview, we did a project looking at both enablers as well as barriers to the adoption experience. How is it unfolded to date? What can we learn? First, this review of alternatives assessment. So we wanted to know what's been done to date. What are the strengths and the weaknesses of those efforts? What can be learned? What's needed going forward? And so we did a broad review looking for existing alternatives assessments on AFFF. And we used kind of 4 criteria to determine what it was that we were going to call an alternatives assessment and include in our review. First, it had to be commercially available alternatives. This is not a definition for alternatives assessments. This is a definition for our need to work under contract with DoD to find alternatives sooner rather than not that can be adopted. So we weren't looking at assessments that were looking at alternatives that were in development, but rather those that were commercially available. The assessment had to evaluate hazard, cost, and performance. Those are three critical elements of an alternatives assessment. We considered the inclusion of other life cycle attributes as well as exposure attributes as optional. They had to use standardized criteria to systematically evaluate the alternative against the incumbent, as well as the alternatives against each other. And the incumbent had to be, the alternatives had to be fluorine-free, and the incumbent had to be one of the AFFF products of concern. And we found that, there were multiple assessments out there. There's a ton of assessments that are going on right now within the Setup program at DoD, looking at issues of performance, lots of performance reports on commercially available alternatives. We have green screen certified. Mark Rossi here with Clean Board Action is kind of the home of green screen certified, who has a program specifically on firefighting foams. That's a great source for information related to kind of the safety. They do comprehensive evaluations of the hazard. So we have kind of informations on the hazard assessment side of things, as well as kind of more topical papers that have been put out by international organizations. But what we found was that let me step back. One thing so part of this review process was to say, how are these assessments, how can we evaluate them against kind of best practice methodologies that are out there? And so with that, we use two frameworks that are commonly used in alternatives assessments that are elevated in the community of practitioners about the guidance and the framework to use when you're conducting an alternatives assessment. And that is one that was published in 2014 by the United States Research Council. And the second is the one that Washington used, and that was described in the session yesterday, the Interstate Chemicals Clearinghouse Framework. And so when we did this review, we wanted to say, what are the methods that are being used? What are the endpoints and the being evaluated? How are issues of uncertainty and data gaps being addressed? For alternatives assessment, this is more just for edification about what an alternatives assessment is and what it looks at. Again, Ray's presentation yesterday went into this. These are the elements of an alternatives assessment, multi-attribute in its look. It typically will look at use criteria that kind of understand and rank alternatives with regard to low concern, moderate concern, high concern against these evaluation components. So enough said about this, because we really want to get into the AFFF story. So we found only one assessment to date, despite all this effort that's being conducted around AFFF and its alternatives, that is an alternatives assessment on the project or on the topic. And this was conducted by Wood and colleagues on behalf of the European Chemicals Agency and the Commission writ large to look at the issue to support future risk management options, which, as we heard, 4 years later, we now actually have a restriction proposal in place. But this report is much bigger than just a analysis of alternatives, which is what they're called in Europe. But this was the only assessment that we actually found that is a comprehensive alternatives assessment on AFFF. And so what the assessment did, it took a very broad view. It engaged stakeholders in multiple workshops through surveys to identify what are the options out there, and help streamline that which was going to be considered kind of the best options going forward. They identified 168, narrowed it to 30, narrowed it to 7 which were shortlisted and included as the main focus of this analysis of alternatives. And these are the 7 that were the 7 products. These are all fluorine-free products that were included in the assessment. Because of stakeholder input, no alternative that was siloxane-based, that used siloxanes as an alternative surfactant to PFAS in these products were included. And so none of these alternatives have siloxanes in them. And so what we found was, our little alternatives assessment kind of practitioner question about, is it how the strengths and weaknesses of this particular assessment. I mean, it was a strong report, especially given that it was conducted by third-party consultants that didn't have, NDAs with all these manufacturers. It was comprehensive in the attributes that it looked at. It was comprehensive in the way that when we kind of compared to what some of the suggested criteria or endpoints are to look either in the IC2 guidance or the National Research Council framework, everything was there. But we definitely derived some lessons, especially for kind of future assessments going forward. The first, I'm going to share 4 with you. The first is to broaden the assessment scope to not just limit the functional use of AFFF alternatives to film-forming foams. So this is, as we heard from Shailene, there's a number of alternatives that might have the potential to extinguish a fire. Film-forming foams work by putting, a blanket over the fire and suffocating it, if you will. That's the mechanism of action. There are some of the alternatives that Shannon mentioned, like NovaCool. It doesn't work by that mechanism. It actually cools the fire, right? And so this is a kind of a limited scope, if you will, utilizing only one kind of mechanism of action to look for alternatives and expect alternatives to achieve a function. For alternatives assessment, we want to ask ourselves, what is the function needed? What alternatives can do that? And this is a very narrow scope. And all I can say is that DoD scope is also very narrow. It also, through the mil-spec, is only looking at film-forming foams. But not only that, it's also putting greater restrictions on the kinds of products that can be used. For example, a lot of the 7 that I showed you are known as kind of non-Newtonian fluids. What we're finding is that they're taking a lot more like compressed air systems to get them to get through the nozzles. And DoD has actually instituted in its draft mil-spec that the alternatives can only be Newtonian. So they've got to be able to flow like water, which precludes a lot of the current alternatives that are out there. That said, it's sparking innovation. A lot of these product suppliers are now innovating Newtonian type products. And so we'll see where that takes us. But this is an issue, how you define what kind of functions you're looking for in order to look, scope the alternatives themselves. This is for the practitioners of alternatives assessment. And one thing that we found really quite notable in this assessment was the use of case studies. Typically, alternatives assessments, we like to use a lot of tables, a lot of graphs, a lot of or matrices that do comparisons, that use quantitative or other qualitative comparative values. And what's missing sometimes in that is the story of the use of the alternatives themselves. You can't understand in full both the potential and the practicality unless you include some of these case studies. And what was brilliant in the report that Wood and colleagues did was utilize the stories of a lot of different airports, industrial facilities in Europe that had actually transitioned. What was that experience like? Did it work? What had to change? And that was really helpful to know what the potential of these alternatives are going forward. Use of case studies is not something that alternatives assessments include, but suggesting that they do so going forward because they give a lot more depth and narrative understanding about what these alternatives might look like for a given user. One additional notable lesson, this particular assessment used safety data sheets for the evaluation of hazards. which, as we know, are quite limiting in terms of their understanding. Our colleagues at Turi have done trainings about going beyond the SDSs in order to really understand what's going on with regard to the hazard of a product formulation and otherwise. It's why green screen actually, requires ingredient level information and conducts, detailed lit reviews and searches of literature and using modeled and measured data to kind of characterize what these endpoints are. But that said, it was also somewhat limited in kind of the hazard of endpoints that were evaluated. Again, if this is done under the auspices of REACH, the Registration, Evaluation, and Authorization of Chemicals, the main chemical policy management regulation in Europe. These products are about replacing a substance of very high concern. So the main attributes, the main endpoints of interest are that they can't also look like and be like a substance of very high concern. They can't be a carcinogen, mutagen, reproductive developmental toxicant. They can't be a PBT, persistent bioaccumulative toxicant, nor can they be a VPVB. Those are the main criteria that are concerned when REACH is kind of trying to go through, when ECHA is trying to do a substitution or a restriction proposal. So there's a number of additional endpoints that are not a focus in that evaluation. That said, the SDSs did reveal some additional endpoints of interest and also of concern. Particularly, some of the alternatives do have aquatic toxicity concerns, and as well as kind of skin and eye irritation concerns. And these were revealed through the SDSs. And so given how the use conditions are, there's a question about, okay, aquatic tox, well, what does that look like? What does that actually mean? And the Setup program is actually sponsoring really deep ecotox research on this very topic, looking at both aquatic as well as terrestrial ecotoxicity studies to try to understand what this really does look like and what would it mean in terms of moving to one of these alternatives. So lastly is just that this is such a fast moving field. Our project support committee, when we talked about this alternatives assessment and they looked at the alternatives, they're like, people have moved on. There are dozens of more commercially available alternatives now available. Again, this issue of non-Newtonian versus Newtonian products, that they thought, yeah, great, 2018 seems pretty recent, but it's highly outdated already in terms of where this has moved. There's been so much innovation because of the money and the global concern that this is going to, or that's been thrown at this, that, there was a deep suggestion that a more current assessment be conducted, one that actually leveraged all the work that is being done within the Department of Defense Setup program. For example, I mentioned earlier, this is a snapshot of an outtake presentation done by Jerry Back, who is a performance kind of testing guru that the Department of Defense has been using, that have highlighted, as Shailene said, their DoD is zeroing in on about 5 alternatives that appear to be their best performers. There's about 3 of those that are on the green screen certified list right now. I don't know what that means because some of these are also non-Newtonian. Again, so these couldn't pass the mil spec as it's currently been redrafted. But there's DoD has also sponsored sustainability analyses on these 5, including some that are in development. They've done cost assessments on them. Again, there's a lot to be leveraged about where DoD is heading, and also some work that we're doing to kind of broaden potentially how they're thinking about this question. One of the third projects that we worked on is this question about fit for performance. And so we heard from Ray some of the limitations in the state of Washington about, regulatory and or specifications that are looking for equivalent performance, comparable performance. And what DoD has done with their mil spec is it's written around the worst case scenario. And as Shailene said, that's not what happens in practice. Yet it's looking for the top of top performers. And that's what's going to be, certified, if you will, for procurement. There's a need to to broaden this, to understand that many alternatives have sufficient performance for an array of applications. So one thing that we would want to do in a future alternatives assessment, or to asset of alternatives assessment, is to think about performance from a more fit for purpose way, and not to necessarily use these standards that are prescribing, in some cases, over performance for the range of uses that are ultimately necessary for this kind of product. And so there's a number of things that can happen in this alternatives assessment, kind of to inform future directions of what DoD, especially because this is our kind of view, is what DoD would do going forward. We've had conversations with them around this exact issue, and they're open to writing additional specifications. Again, they're concerned about mission critical issues and operations. AFFF came about because of a horrific fire on board a ship with munitions. So they're thinking about the worst case scenarios. But again, they can write additional mil specs that would allow for much broader use of the alternatives that are out there for different kind of use conditions and operations. And they're open to considering that going forward, but kind of need to see how that would unfold. So I guess I want to end on, maybe I'll just bookend this with Shailene's statement. So one of the additional projects that we looked at or conducted was this question of, all right, alternatives assessments, all well and good. The rubber meets the road around implementation. What's going to take for us to have effective substitution of these safer and feasible options? And I just want to kind of land on 4 lessons. We interviewed around 20 or so key informants, fire marshals in the States, who were they all? DoD procurement officials, fire suppression experts, European defense industry, environmental health and safety experts, airport firefighting personnel in Europe, US, and also in Australia. Kind of again asking, what's worked, what needs to happen, what's kind of standing in our way for like effective implementation of these substitutes. The first thing that we heard is just the need for more collaborative performance testing and demonstration sites. So Shailene mentioned a number of these standards: UL, last fire, even the mil spec. The standards are written around kind of a demonstration, a proof of concept test. And the mil spec is a 20-foot square pan fire. And a lot of the users are saying, but I don't know if this is going to work for me. And this is especially true of some of the militaries that haven't transitioned in Europe, where I want to know that if that plane is on fire, does that 20-foot square fire reflect what's going to really happen in the real world? And so there's been a number of efforts, last fire as well as the Department of Defense, to use more large-scale fires to see how these alternatives are working in practice. And so one of the things still going forward is to get some of these holdout stakeholders that are resistant to change to be a part of these collaborative performance testing projects to see what these real world application fires would look like and how it would work for them. The second is just this issue around, there's so many questions about this transition, and Shannon mentioned many of them that now the states are going through. And one of the main things that we heard is that there is no comprehensive national implementation strategy. There are way too many questions than anybody has answers to. Everybody knows that this is coming, but when all the questions that Shannon raised and had to kind of figure out on their own and is developing a standardized operating protocol to help others navigate this, there's no national strategy, and we need one. Third is the issue of education and training. This is also part of the roadmap that an NFPA is dealing with. What we heard when they were doing some of these large scale tests is that it does take a different kind of practice of firefighting to use these foams. Number one, it's been years for some fire personnel that even trained with the foams. And second, the newer foams do supposedly act different. So it's kind of a no-brainer to just assume that training is necessary, but many are saying that training and education need to move alongside the development and adoption of these alternatives. We can't wait until they're deployed to have the education and training happen. And lastly, it's just this issue for ongoing monitoring. No alternative is going to be perfect. And so there is going to be a need to adapt, to evolve, and we need systems in place to track that. We need to get out of the use of these PFAS products, but no alternative is going to be a panacea. And so we have to be prepared to create these ongoing monitoring programs and processes to adapt, to correct. It's just what we need to do. And with that, I'll conclude.
Okay, I think we have a few minutes for questions.
I don't need the mic, just.
Well, no, actually, we have people online, so we do want to.
I'll be really quick. I don't see any of the charts online. Will they be available?
The charts.
The slides.
Yeah.
I don't see any on, none of these are online.
Yeah, if all the panelists can make sure to upload on the Whova app, we'll get online. Yeah. And I think we heard earlier that there has been some slow migration. Next question.
Shannon, you mentioned that you had hoped to treat the flush water and maybe the water that went through to clean the systems, but that was not successful. Can you talk about that? Because it seemed like that first flush, you removed a lot of just water, but now you have a lot of water to manage.
Right. So, so part of what the consultants were doing was filtering out the PFAS to reuse their cleaning solutions. So that was a waste minimization strategy. But in the end, for disposal of the wastewater, in Connecticut, we don't, well, the discharge limit to discharge PFAS containing wastewater to either a sewage treatment plant or to surface water body is non-detect at the low parts per trillion level. We did not achieve that with the technology that was available on either test site. Okay, it was, yes, it varied by vendor, but it was generally carbon. Yeah, I know there are exchange resin, ion exchange resins that could meet that, but this is what we had, and then we had time constraints. So
what I've seen is the other surfactants present a big problem.
Yeah.
What I've found trying to treat the AFFF solutions is the other surfactants that hopefully you can treat biologically or some other way, that if you get them out of the picture, maybe you can treat with carbon. So that's what I've experienced, and we're going to try that out.
interesting. I'd be interested in following up. Thank you.
Yeah, my question, Shannon, was along the same lines, right? Treating that AFFF that we've done on site, was that part of that project? Was that a goal, or was it cleaning the fire trucks was the bigger goal and then dealing with the wastewater later?
Well, I thought I wrote the RFP clearly, but neither consultant grasped that. So it was sort of an after the fact, oh, wait. So I think with, both consultants are going back and reassessing for the second phase. So we'll see what the proposals are.
Thank you all for the talks. This is mostly a question for Molly, but I'm curious what others think. You mentioned that sort of continually updating alternatives assessments would be a great practice moving forward. And I guess I'm wondering if you can speak to either thoughts you've had about how we might fund that, given that oftentimes these assessments are done in response to current problems and there's only current funding available for them. And if there's limited funding, what sort of elements of the alternatives assessment to your mind would be most important to keep updating?
And I said continual in the sense that if a field is rapidly evolving as this, right? Like, again, the information that was just in the ECHA assessment, there's so much more now, right? So in those situations, and when critical decisions are being made to move in certain directions, and if information is outdated from a previous assessment, it's worth updating it. I'm not suggesting that it's practice to keep doing alternatives assessments, but under conditions like we're in now with AFFF, it makes sense. And so, I think in this respect, with the current, with what's happening currently, that a full alternatives assessment is necessary. I think going forward, certain components, whether it be, cost related issues, many of the costs of these products are quite similar. We have heard that they kind of take more product to actually use. And so they can be a slightly more expensive from the volume needed perspective. But I would, costs wouldn't need to be updated. Issues of performance, perhaps, especially if there's different functionality or mechanisms of actions that are being used, then, what we're seeing in a lot of the products is many of the ingredient formulations are quite similar. They're using the same kind of surfactants. They're using the same kind of solvents. They'll probably act the same as a result. If the formulations are quite different, they're taking on more novel chemistries, you might want to understand what that performance looks like, and moreover, what the hazards looks like. So I think those are ultimately two of the most critical pieces that, update as needed would be questions related to performance and questions related to hazard and safety as new products come on.
So Molly, when is the DoD publishing their report?
So again, we had 4 kind of work products that were associated with this project. The one that I spoke to right now, actually, we do have a final report around in terms of the review of existing alternatives assessments. Our website at Lowell is being updated, and so I don't have like a link to share it with you. But if you're interested, send me an email, and I'll be sure to get it to you. And the other 3 reports, one of which, again, because DoD is going to be conducting its own kind of hazard evaluations for certification for procurement, we put out a report on, based on some documentation or reports from OECD, also kind of criteria used in a green screen certified, and criteria used in the state of Washington to make a safer alternative decision. Criteria that DoD should use going forward. The mil spec actually has environmental performance requirements in it. It would be nice to actually supplement those further about, what that is under review by DoD. Fit for performance kind of assessments is under review by DoD, as is this review of kind of enablers and barriers to kind of a substitution going forward is under review. We're hoping that they'll give us feedback and we can get them published within the next couple of months. And they'll be on our university's website.
Okay, I think it's lunch. Thank you all for your patience during the fire alarm. And don't forget to fill out the evaluations. NUMOA really needs those to help plan for the next one in 2 years. Is that it, Terry? Thank you. And thank you to our 3 presenters.
Actually, a question for you.
Uh-oh.
Uh-oh.
I'm on another session. Can I